What do we get if we integrate an odd function? For instance, what happens when we integrate the function sine x from -1 to 1, right? Sine x is an odd function. Consequently, it looks like the answer is 0. Remember, the integral is at least morally calculating signed area. So it's going to be calculating this area here, but with a negative sign. And it's going to be calculating this area here as actual area, right, with a positive sign. And these two areas are equal, but the integral is going to count this area with negative sign and this area with a positive sign. So the integral should cancel and the answer should be 0. But if you don't believe the geometry, we can work it out algebraically. So algebraically, I'm trying to integrate from -1 to 1 of sine x dx. And the first thing to think is that, well, if I'm integrating from -1 to 1, I can rewrite that as an integral from -1 to 0 of sine x dx and add to that the integral from 0 to 1 of sine x dx, right? If I want to integrate all the way from -1 to 1, it's good enough if I just integrate halfway and then integrate the rest of the way, and they're just two separate integrals. Now, how do I integrate from -1 to 0 sine x dx? Well, if we think a little bit about what this really means, that would be the same as integrating from 0 to 1 of sine minus x, right? If I want to add up numbers from -1 to 0, it'd be good enough if I picked a partition from 0 to 1 and then evaluated sine at negative those values. And you have to worry a little bit about how this dx changes, but we're going to be looking at that in the future as well. Okay, and I'm going to add to this the integral from 0 to 1 of sine x dx that I've got right there. Now, what's sine of negative x? That's negative sine of x. And here I've just got sine of x dx again. But now I've got the integral from 0 to 1 of negative sine dx plus the integral from 0 to 1 of sine dx. Well, I can pull this minus sign out of the integral, right? If I'm integrating just a constant times something, it's the same as that constant times the integral. And now I've got negative something plus the same thing, so that is equal to 0. Now, in the future, we're going to see more how to justify those steps that I took algebraically, right? Why are all those steps actually valid? But in the meantime, the upshot here, the takeaway message, is just that symmetry can be exploited to calculate some integrals, right? You can evaluate the integral of an odd function as long as you're integrating symmetrically across 0. You can evaluate that integral to be equal to 0 by exploiting symmetry.